Hi, I'm John Leidel, Chief Scientist at Tactical Computing Laboratories, and this is the RISC-V Everywhere, from IoT to HPC. A little bit of history behind Tactical Computing Labs. I'm actually the company founder. I founded the company in 2016. We're currently based in a little town called Munster, Texas, which is north of the Dallas-Fort Worth General Metroplex. We are a small business. But interestingly enough, we have employees in Texas, California, New Jersey, Delaware, South Carolina, and that list is actually continuing to grow. We're 100% remote. We do have some physical offices, but we allow people to have a fantastic work-life balance by allowing 100% remote work with no minimum amount of travel required. Unlike some of the other RISC-V organizations out there, we actually operate like a private research lab. We operate in a very similar manner to a national lab, except we are 100% private, which allows us to work on some very interesting, I guess more advanced computing and research and development projects, much further beyond what most large organizations are willing to work on. We're 100% employee owned, and we have no venture capital, no external investment, which effectively means that we are allowed to operate in a manner that allows us to go and very quickly and in a very agile manner pivot to very interesting projects. There are two main company principles, myself being one. I have about 20 years in experience in high performance computing. When inside TCL, I actually lead application development, compiler development, and performance analysis projects. Whereas my business partner and the other company principal, Mr. David D'Onofrio, he also has about 20 years of experience, but in FPGA design, ASIC design, and prior to joining TCL, David was actually the architecture lead for Lawrence Berkeley National Lab. And as a company, what we're really seeking to do is change the face of high performance computing by merging these concepts of co-design and traditional hardware software architecture design and development in order to really spur some interesting change in the industry as a whole. And so we do this by attacking this in three ways. So first, we have your basic system architectures, your system architecture concepts, we have algorithm design, and we have software architecture design. So on the system architecture side, we look at processor architectures, we look at memory architectures, and we look at interconnect architectures all the way down to the physical level. On the software architecture side, we deal in compiler architecture. So right now we have about half a dozen different compiler or compiler extensions in development. We look at development tools, and we look at runtime architecture. And on the algorithm side, we look at just pure algorithm porting and optimization. We look at numerical libraries, and we look at what we call architecture exploitation, or how do you build new algorithms for novel architectures, largely based on RISC-V. And all these concepts we actually build using various different baseline or extensions to the RISC-V ecosystem. So we work in all levels of the design, algorithm, and software architecture areas in order to build truly efficient hardware-software co-design ecosystems using the RISC-V ISO specs. So one of the interesting things about working here at TCL is our industry research opportunities. So since we operate much like a national lab, we actually encourage advanced research. Many of our internal researchers actually find new research opportunities that we build proposals for. We get funding for both in private industry and through national labs and other different government sponsorships. And these turn into some very interesting projects. And the interesting thing about this is, even though they are actually built using an industry-based organization like TCL, a lot of them are very open. In many cases, they're completely open source. And from that perspective, we allow all the researchers inside to actually publish their work. So we continually publish, we sponsor the travel and all the necessary accoutrements to go to academic and professional conferences. We do a lot of participation in the RISC-V Foundation. I'm actually the co-chair of the Special Interest Group for High Performance Computing, as is my colleague David. And I'm also the chair for the Technology Horizontal Committee, which oddly enough, the SIG HPC actually falls under. We also highly promote our internal engineers and researchers to participate in other community organizations outside of just the RISC-V Foundation, things like the LLVM Foundation and the LLVM development ecosystem, the Apache Foundation, and the Apache, various different Apache-based development projects, all the way out to things like Linux kernel development and other various different Linux Foundation organizations. But more importantly, all this really boils down to the fact that we really want everyone inside TCL to grow and continue their professional networks with open collaboration. We absolutely expect everyone to continue collaborating with their current or former and potential future colleagues in and around computer science, computer architecture, and high performance computing industries. And we do this with just as a couple of examples with a few of the projects listed here on the right. The OpenSOC System Architect project is a rapid co-design framework that we actually developed inside TCL. It's completely open source. The entire infrastructure is open source. It's licensed under an Apache 2.0 license, and we have roughly half a dozen publications of the various different designs that we've pushed through System Architect. And basically, the whole goal behind System Architect is to take a design specification, compile it down to something that's discernible, and output Chisel and an LLVM compiler from that design specification. Another interesting project is the XBGAS project. We're actually developing extended memory semantics for the RISC-V ecosystem, and this would effectively allow us to do distributed global shared memory on an HPC system using just basic microarchitectural techniques. The final one listed here is what we call the REV simulator. REV is actually a component inside the SST parallel discrete event simulator infrastructure that allows us to do cycle-based experimentation with a simulated RISC-V core inside a very large-scale, scalable simulation infrastructure like SST with a cycle-based cadence. So in terms of the current opportunities available here at TCL, we're actually looking for two classes of individuals to come in and join our research teams. One is an HPC hardware engineer, where that person would be interested in processor design, FPGA development on both Xilinx and Intel platforms, and also potentially ASIC development. We do a lot of Chisel work here inside TCL, but Chisel is not entirely required. Verilog VHDL are also fantastic, but this position is 100% remote with no travel required. So if you're interested in doing RISC-V hardware development, we absolutely want to speak to you. On the other side, we also have positions available in the HPC simulation developer world. We have a number of interesting projects coming up where we're actually developing some scalable HPC infrastructures and architectures or architecture extensions using RISC-V, where we're doing a tremendous amount of modeling and simulation based largely around Sandia's SST parallel discrete event simulator. So this individual is going to have strong C++ and Python development experience, but not necessarily rooted entirely in SST. So if you have experience in Gem5 or QEMU, this would be a fantastic position to consider. Also 100% remote and no travel required. So if you're interested, check us out at techcomplabs.com/jobs. Thank you very much for listening to my talk.